The next phase of developing a nutrient balance sheet is to calculate a manure application rate that will meet the net crop requirements for N, P2O5, or K2O. If you aren't familiar with how to calculate the net crop requirements, or even what a nutrient balance sheet is, then go back and review the introductory and part 1 videos in this series. To determine the manure application rate that will meet the net crop requirements, we need to know several pieces of information. First, we need to know the manure nutrient content. This is best achieved with a manure analysis. If you are doing nutrient balance calculations for an Act 38 plan, or if you are developing an Act 49 balance sheet for manure exported from an Act 38 operation, then manure analyses are required. If you are developing a nutrient balance sheet for a manure management plan, then you can use typical nutrient contents of manure, what we call book values, for different manure types as listed in Table 1.2-13 of the Agronomy Guide, or Table 1.2-10 of the 2021 version and beyond. Then we need to determine how much of the nutrients in the manure will be available for the current crop. For phosphorus and potassium, it's easy. We treat 100% of the P2O5 and K2O in the manure as available. For nitrogen, it gets a bit more complicated. The nitrogen in manure is made up of two components, ammonium nitrogen and organic nitrogen. Ammonium nitrogen is a soluble mineral form of nitrogen that is immediately available for crop uptake. However, the ammonium nitrogen can volatilize into the atmosphere if the manure isn't incorporated into the soil quickly. Ammonium nitrogen applied with manure in the fall may also convert to nitrate and leach out of the soil over the winter if a winter crop or a cover crop isn't planted to utilize it. The organic nitrogen in manure is bound up in complex organic molecules like proteins that need to be broken down or mineralized by soil microbes before it is available for plant uptake. Only a fraction of the organic N will be mineralized into an available form in the first year. Based on these processes that regulate the availability of the ammonium and organic N components of manure, there are tables in the Agronomy Guide that can be used to determine the fraction of N in the manure that will be available to the crop based on the season of manure application, the season of crop utilization, and how quickly the manure is incorporated into the soil. The first table I want to discuss is Table 1.2-15 in older versions of the Agronomy Guide, or Table 1.2-12 in the 2021 version and beyond. In this table, there are separate availability factors for the ammonium N component of manure and the organic N component of manure. For the ammonium N component, the availability is based on when the manure is applied, when the crop will be utilizing it, days to incorporation, and the type of manure. For the organic N component, the availability factor is based on the season of application and the type of manure. Based on the plan management for any given manure application, drill down into these tables to find the availability factors for ammonium N and organic N. Then multiply these factors by the ammonium N and organic N contents of the manure being used to get the quantity of available N in the manure. Let's do an example based on a dairy manure slurry that has an ammonium N content of 9.8 pounds ammonium N per 1,000 gallons and 17.2 pounds of organic N per 1,000 gallons. Let's say the manure is applied in spring for use by the summer corn crop and incorporated into the soil in 2 to 4 days. Using Table 1.2-15, the availability factor for ammonium N is 0.4. The availability factor for the organic N, based on a summer crop, is 0.35. We multiply these availability factors by the ammonium N and organic N content of the manure to get the available N. There will be 3.92 pounds of available ammonium in the manure and 6.02 pounds of available organic N, for a total of 9.94 pounds of available N. This is the amount of available N in the manure that we would use when calculating a manure application rate to meet the net crop requirement. There's another table in the Agronomy Guide that offers a slightly simpler calculation of available N in the manure. It's Table 1.2-14 in older versions of the guide and Table 1.2-11 in the 2021 version and newer. This table has availability factors that would be multiplied by the total N content of the manure, and the factors are based on similar aspects of manure application management as we previously discussed. Multiplying a single availability factor by the total N content of the manure, rather than separate availability factors for the ammonium and organic N contents, provides a simplification but relies on an assumption that the manure being used has a distribution of ammonium and organic N similar to the typical manure of that type of animal. If the manure you are using is atypical, such as digested manure, compost manure, manure that has had the solids separated out, or even manure from a storage that is not agitated prior to emptying it for spreading, you will get a much more accurate result by using separate availability factors for the ammonium and organic N components. And in fact, in an Act 38 plan, this is required for any type of atypical manure. Let's look at an example of using Table 1.2-14 to calculate available nitrogen in our dairy slurry. The slurry has a total N analysis of 27 pounds per 1,000 gallons. Based on application management of spring spreading for a summer crop with 2 to 4 days until incorporation, the availability factor for total N would be 0.35. Taking our total N analysis in the manure of 27 pounds per 1,000 gallons times the availability factor of 0.35 gives us 9.45 pounds of available N per 1,000 gallons. This result isn't too different than when we did the calculation based on ammonium and organic N components separately, and that's because the manure has a fairly typical distribution of ammonium and organic N components for dairy manure. Going back to our template for completing a nutrient balance sheet, we can see that it has some cells available to help us through the calculations for available N in manures if you know how to use them. But it's also good to know the fundamentals of how the calculations work by heart and be able to recreate them without a balance sheet template, because you never know when you have to do the calculations on the back of an envelope or maybe even a napkin. In the balance sheet, enter the ammonium N and organic N fractions. If you use availability factors for the ammonium N and organic N components separately, look them up in the tables and enter them here. Multiply the ammonium or organic N content of the manure by the availability factor to get the available N content. Then add together the available N from the ammonium and organic N fractions to get the total organic N. If you prefer to use the simplified method of calculating available N based only on the total N content of the manure, look up the availability factor of the total N from the table, write it here, and multiply by the total N content of the manure to get the available N content here. Since 100% of the phosphorus and potassium in manure is considered available, we can simply add the P2O5 and K2O contents of the manure from the manure analysis or book values into the nutrient balance sheet here. Now that we've determined the amount of available nutrients in the manure, we can calculate how much manure needs to be applied to meet the net crop requirements for N, P2O5, or K2O. The math here is fairly simple, but sometimes knowing how to set it up and keep track of the units can trip people up. Here's how I like to think about the problem. On one side of the equation, we have the net nutrient requirement of the crop in pounds nutrient per acre. The result we want to calculate is a manure application rate in gallons per acre. To make the units convert, we need to multiply our net crop requirement by some ratio that reflects the nutrient content of the manure. The ratio to use is that for every 1,000 gallons of manure, we have a certain quantity of available nutrients. Plug in the available nutrients from your manure analysis to the denominator of this ratio and your problem is set up. Essentially, you're just taking the net crop requirement, dividing by the available nutrients in the manure, times 1,000 gallons. Let's calculate the balanced manure rate for the N, P, and K net nutrient requirements of this crop. For N, it's 60 pounds N per acre required, divided by 9.94 pounds available N times 1,000 gallons, gives us a 6,036 gallons per acre application rate. For P2O5, it's 20 pounds P2O5 per acre required, divided by 12 pounds P2O5 in the manure times 1,000 gallons for 1,667 gallons per acre as the phosphorus balanced manure rate. For K2O, our net crop requirement was 0, so the K2O balanced manure rate would also be 0. So now we've calculated the different manure application rates that would provide the correct amount of N, P, or K to meet the respective net nutrient requirement. But what rate will the farmer actually use in the field? That's what we call the planned rate, and how to choose a planned rate and calculate the nutrients applied in that planned rate is the topic of the next video in the series. I'll see you over there.